Hello and welcome back to the fundamentals of NumPy tutorials. In this section, in previous sections, we've talked about modifying arrays and also um, reshaping arrays. In this section, we will be talking about flattening arrays. How do we flatten an array, or what's the flatten operation really? This is basically because in deep learning and generally when you're working with NumPy tutorials, you would most likely be working with arrays in multiple dimensions, not just one dimension. But there will be need to, at some point, especially maybe when at the output of your neural network in the deep learning situation, you would need to make your multidimensional array into one dimension. So the process of making your array from multiple dimension into one dimension is what we call the flattening operation. And there are different ways to do that. Excuse me. So first, NumPy gives us a method called flatten to perform a flatten operation. And as always, before we start with that, I'm going to create a new NumPy array because I don't want to pollute the previous arrays we used in other sections. So I create a new array K, which has 5 rows and 6 columns. It's a two-dimensional array. And then, so if I print out K, I should have this 5 rows and each row has 6 columns. So yeah, so now I could choose to flatten I want to flatten this actually because that's what we're doing here. I don't have a choice, I have to flatten. I could choose to flatten, sorry, I will be flattening this into a 1D array by calling .flatten in it, right? And so when I run this, everything becomes a one-dimensional array. Just so that we're sure. Okay, I forgot to run. I should have run. I should have printed out the shape of this. Oh, sorry, I flattened this, so I don't have your. I should have created a copy, but here, if I print out the shape of this now, I would get. Oh, I see. Yeah. So it's still showing me the shape of the original array, which is good news because I wanted to show you the shape of the original array at first. So it's 5,6. So what we should be doing here is I need to be sure I haven't. Yeah, okay. All right. So I will. So what happens is it doesn't flatten in place. You have to store the results in a new array. So I call this K1 and then I run flatten again. And okay, I should have done this K1. I print it out. And so I can see this now. When I print out the shape of this, it's basically 30, right? Because everything has been flattened into a one-dimensional array. Now look at the order in which it's been flattened. It prints out the first row. If you compare it to the original array, it prints out the first row. And rather than creating a new row, it takes the second row and continues in the first array. And so it stacks the array on each other into a one-dimensional array, right? That's the default order in which flatten operation for NumPy works. Now, another way to do that, to use the flatten operation, is to specify what order in which you want it to be flattened. Excuse me. And we can just flatten along the column. So we specify the column. So the flatten operation has different arguments it takes in. I think you can specify C, F, A, and K. I don't think we'll be looking at A and K in this. No, we shouldn't be looking at that. So we just want to specify along the rows and the column, flattening along the rows and the column. So in this case, I want to flatten along the column. What that means is the original array, I want to pick elements from each row. I want to pick elements. I want to pick elements from the first column of all the row first, then elements from the second column of all the rows, and then from the third column of all the rows, all the way till we get to. So we're basically starting along the columns. Let me just run this so you see. So you can see compared to, yeah, I think we can collapse this so you can compare the original array and the new one, the flattened one. But sorry, I'm supposed to do this as K2 because like we established, it doesn't change the original array. So yeah, this. So when we flatten this, we get the next element here. The next element here is not from the first row. Instead, it comes to the first column of the next array. The third element is this. That's in the flattened format, in the flattened result. And then the fourth element, the fifth element. And now the sixth element comes back here, starts again from here, and keeps stack. So it takes all the columns first, or the first. It takes all the first column first, prints it, puts it in an array. Take the second column, puts it in the element of the second column, and puts it in an array that way till it flattens everything. So that's how flatten work. Another way to flatten array is to use Revel. So we will run this to see how this works. And it's basically the same as this. It's basically the same as the default. Sorry, I need to close this so you can see. So Revel is basically the same as calling flatten. It's just an alternative function to using flatten, right? So we'll name this as K3, right? And we see that it's the same. So you can choose to use flatten or Revel. And then another way we can flatten is with Reshape. Remember, we used Reshape to change the dimension of the array, like went from maybe a 3 by 4 by 5 array to a 2 by 3 by 10 by, or 3 by 3 by 10 array, so long as the product of the old and new dimensions match up, right? So in this case, we use Reshape in a different way. Rather than passing the dimensions that match up to the array, to the product of the original shape, what we do in this case is we just pass in -1 to it. So when we pass in -1 is kind of sort of like a false value, so to say, for lack of a better way to explain that. So when you say -1 is not it's not a valid value. So we say that just combine everything together and give it to me as a 1D array. And that's basically what this does. So when we flatten across, when we reshape with an argument of -1, it basically just flattens the result for us, right? So K becomes a 1D array when we use reshape -1. We would call this K3, yeah, sorry, K4. And then I run this again, it's the same. And I would just quickly go through what the difference between flatten and Revel is. So flatten, they work the same way, like I said, but there's an underlying difference in how the results are created, right? So let's create a new array here. We create a new array test, right? And then we flatten both arrays, right? And then we get the same result, obviously. And now I want to modify both arrays. I modify the flatten array at this point, and then I modify the revealed array, the first index. Now here's the thing. Now here's the issue. Now when you flatten, you create a new array. not, it doesn't copy it doesn't do a shallow copy of the existing array. So it creates a new array and flattens it, right? But when you call revel on a NumPy array, what that does is it basically creates a copy of the original array and then flattens that. So because with flatten, it creates a new array with the same elements. There's no reference to the original array. So when I modify an element in the flattened array, it only modifies that element in the flattened array. It doesn't modify the original array, right? The original array remains the same at that index. But Ravel creates a copy, and it's basically referencing the original array. And so when I modify an element in the raveled array, because it's a copy of the original array, it also changes the value at that position in the original array. And that's basically the difference between using flatten and using ravel. So be careful of the slight differences when you try to call either of the function. If you don't mind modifying the original array, then go ahead with ravel, otherwise use flatten. So that brings us to the end of flattening arrays. We'll next be going through squeezing and expanding arrays. See you in the next section. Thank you.